No sound, Zach.
What?
No
Okay.
sound.
No curve, there ain't no ball. The globe religion about to fall. We're gonna open your eyes so you can see who you're gonna call if you wanna be free. Globebusters! 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 Who you gonna call? Who you gonna call? Who you gonna call? Yeah! Globebusters! 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 And welcome everybody to Globebusters.
Hello, everybody, and welcome to another edition of GLOBEBUSTERS Tech.
Sorry.
I'm your host, Zach. Good times for all, and today we'll be talking about
geez.
crystalline knowledge.
No, we won't. I am so sorry about that. That was the old show. I was just playing the intro for it on accident. Hello, everybody, and welcome to GLOBEBUSTERS Tech. Today we'll be asking you a question instead of really stating it. Triangulating the sky. Can we do it? Now I know we can do, navigation by using stars and the luminaries, but as far as triangulating one of the luminaries from 3 different points on the ground, it doesn't seem to work really in either model. There's all kinds of different things you have to take, put it into equations and stuff like that. So today we're going to take a look at, is triangulating the sky almost like triangulating underwater? As you're looking through the water and there's an object underneath it, if you were to shoot at that object that you see, you're not going to hit it because it's not actually there, it's somewhere else. So we're asking the question, are the things in the sky similar to the things that are below the water? But before we do any of that, we're going to jump in and say hello to everybody on the panel here today. Starting off, we will start with Cami Nodell. Cami, how are you doing today?
I'm doing just fine. And one of the things that we've had requested in the chat a lot is not just leaving the thumbnail up, that people want to see us. They either want to see us or visuals. So, hi everybody, we're here. We're here live. We are listening to the things, and we really appreciate your patience while we're figuring out how to work the tech and getting the things together. But it's like a fabulous discussion that I'm watching. I'm listening to debates. I'm listening to people argue it and us fight it, and all of the time wasted. And I got to thinking about it. What would make us think that we could triangulate the sky? I know that when you're spearfishing and that, they give you formulas that things are not what you see. I know that there are a lot of things going on between us and the sky, and they seem to isolate. They seem to compartmentalize each one of their physics, and why each one of these physics work in isolation for like a globe model type of thing. When you really start to drill down on it, it doesn't make a lot of sense. We're going to keep on. We're going to take it a lot further and introduce on down the panel. Next, we have Karen B. Hi, Karen. How are you tonight?
You're muted if...
Yeah, I'm sorry.
No worries.
I'm fine. I'm great. How are you?
Good.
How is Flattoberfest coming along?
It's coming along great. It's great, I'm still in, I still have a lot of work to do, but it's chugging right along. Let me turn my light up a little bit. There we go.
There she is.
But yeah, did a lot of yard work today.
Oh, it feels good. I love doing yard work.
Yeah,
It was hot out there today, though.
very hot. Yes. And Ted
Said
and I were out there
98.
sweating our butts off.
Yeah.
Yeah.
It's always good for you, though. All right, next up, we have Skylar from the Troubling Tribune channel. Skylar, how are you doing this evening, sir?
Doing fantastic. Excited to be a part of another amazing edition of the GLOBEBUSTERS tech. Ready to dive right in. Triangulation of the sky. How wild. I always hear when you think of that, like plane sailing, triangulating from the sky to like find distances on Earth. But like how accurate are the distances to the things and the things between each other? I have no idea. Excited to get into it.
Absolutely. And last but certainly not least, Mr. Kyle Adams. Kyle, how are we doing this evening, sir?
I'm doing fantastic. Always busy doing all kinds of research on everything. It's tough to stay focused, man. I'm telling you.
Yeah, once this gets, the veil is taken off your eyes, you kind of want to re-look at everything you've ever been taught just to make sure that what you were told was actually the truth. Yeah, I'm still going through that. Yeah, I go in kind of waves, like a radio frequency. I'll be in hardcore research, and then I get back to the center where I'll do like experimentation, and then I go down here and I have to do like just a download, I call it, where I don't experiment, I don't research, and I just let all that information, and I sit and think about it a lot, but I let it all just kind of soak in and get into my brain before I try learning a bunch more stuff. I found that I retain a lot more when I do this.
Yeah, you're onto something when one thing just leads to another, which leads to another, and it just like you're continually learning new stuff that you didn't know before, and just like, whoa, look at that! Oh, look at that! And it like gradually, like you've got this snowball effect of information, and it just gets bigger and bigger, and yeah, it's crazy. It's really cool. Yeah, when your mind becomes enlarged when it comes to all this kind of stuff, it really makes a difference.
So I have a couple videos here that I just wanted to show. This one, oh, here, look, you see this guy's face right here, this epic bow fishing in shallow canals. Now, his face is his reaction because he hit the fish where his buddies told him to shoot it in the water, and he cannot believe that it actually hit the fish. I'll show you right here. He's going to be like, what? It was way down. Yeah, this one blew my mind.
Low and slow. That looks good.
Oh, he doesn't believe it. Look at him.
There it is. Now reel in your catch. 100%. Reel in your catch.
And yeah, I've never gone bow fishing. I've shot arrows into water at fish, not trying to reel them in, just trying to shoot at stuff with the bow and arrow. At a young age, probably shouldn't have had a bow at 12 years old without adult supervision, but
Perfectly legal.
yeah, you go to your buddy's house and a couple bow and arrows laying around in the garage, and yeah, we had fun like that. But yeah, and I never ever hit one. That was the thing. I took like 3 or 4 shots. We didn't use a lot of arrows. We didn't want to get in trouble, and just losing a couple arrows wasn't a huge deal with his dad. But yeah, I never even came close. I mean, the fish would always swim off, but I was a pretty good shot with the bow. We used to practice a lot, and when you're standing 5 feet from something, it's hard to miss when you were good with the bow. And I could never believe that I'd never hit one of those fish, but now I kind of understand why. It's because that fish isn't really there.
Or they're just lightning fast.
Yeah,
they swim way faster than your boat, than your arrow can even fly. Right.
Now this one, I just wanted to show. They talk about atmospheric refraction in here with the sun. This is sunearthtools.com. I just found this today. Really neat. I was trying to find it at the U.S. Naval Observatory, but I guess I don't want to get into it. Okay, they've gone way backward. They had a great site, all kinds of information. Push of a button, you just type in a couple keywords and it was so easy. And now you can't even get the azimuth altitude for like each hour of the day, let alone each minute like they used to give you. It's sad. But I did find right here, this is what they used to tell you at the bottom of every page at that site. To reduce the atmospheric refraction in sunrise and sunset, we assume a negative 0.833 degree. Now, I know that sounds really tiny, right? 0.833 degrees, that's not that big. Well, that's over the distance, the width of the sun. The sun is only half a degree in the sky. So this is almost 2 suns in the sky. And what they're saying is that you're not actually seeing the sun yet. When the sun comes up, it's actually still beyond where you can see, and refraction is, bending it up for you.
But what
I don't
about
know.
that 15 degrees per hour that they always spout off? Wouldn't that go right out the window if that's the case?
Well, yeah, that's the thing. It's when you build your house with a bunch of playing cards, it's not very sturdy, and it only takes, you pull out 1 or 2 of those, and then it doesn't work anymore.
I've got this great video from Neil Tyson where he talks about this atmospheric refraction and how it causes the sun to set every single day, or how we see this refraction while the sun sets every day. So exactly what you're talking about.
Yeah, but if you wanted to get into the sun, I used to do this a lot. This is neat. Look at that. It tells you from wherever you
Yeah,
place it.
SunCalc does that. If you go to suncalc.org, it has a specific to your location. It has a big swoop like that. That's the one we used to use a lot when I very first started getting into this.
It has the analemma right here.
Mm-hmm.
This is neat. I'm gonna have to go through this. I used to really be into the sun and taking measurements and things like that. And by the time I got done, after 8 months of doing it every day, 3 pictures or measurements a day, if it was possible. Well, for one, it became November in northern Indiana where you don't see the sun anymore. It's cloudy. And 2, it was starting to drive me mad because I knew less about the sun than when I started. It just doesn't, it doesn't make sense.
There's so much more to it than, just what basically meets the eye, right? There's so much more to it. And so all the globe earthers, they point to, we just see the sunset and that's all there is to it. And they just immediately think that it's just that what you see is what you get, but it's very clearly not. And that's what you're talking about. There's so much more that's causing the effect of sunset than just what meets the eye.
Yeah, absolutely. I'm trying to find some of these old sunset videos that I did. Oh, I'm sorry. There was the measuring the sun.
Yep. I did a video on that, on how to manually measure your magnetic declination on my channel if anybody wants to do it. There's also a link to the protractor to download in the description.
I would like to, if possible, I'd like to like roll it back a little bit because I think we're jumping into without really presenting what we're talking about a little bit. So is that okay if I like just share a screen a little bit and bring the audience to everything?
Mm-hmm.
Yes.
Okay, let's see if we can figure out how to share a screen. Settings, present.
I love that guy's face right here though. That was just great. Yeah, that was like my face after my 3rd shot. Like, why didn't I hit that thing? It is so off of where you think it is.
Okay, we're just gonna
sharing.
We're sharing, and we're gonna share you what we're thinking, and like how the thought process works on the little group with the tech. I have a thought that I want to run by you all to see if I'm missing something. is regarding triangulation and how people are trying to reconcile the sky with it. This is on both sides of it. Correct me if I'm wrong, but I don't think it's possible to triangulate through different mediums, i.e. think of spearfishing. So for every foot of depth between the fish and the water surface, you can aim 6 inches below your target. I've seen the bow fishing. Think about that. And again, how your angle would affect it, where you were in the water, looking how much water you see for it. So for every foot of depth you see between the fish and the surface, this is just a medium. So you take like that just to start off with, and know that they say that we have an atmospheric river going above us and moisture, and so what you're going to see above you is going to be a lot different than what you would see at horizons or different angles. Again, these numbers are going to say somewhat steady within where you are in location, but they will your angle will have a lot to do with it. Between the sky, we have a known atmosphere, trying to read it because I have a thing, or atmosphere, however you want to call it, filled with moisture and particulates. We have a known magnetic field that it only knows how to distort. It only knows how to move things. It will be a consistent pattern, but a magnetic field has an optical effect. It does not know how not to have an optical effect and how to shift things or distort. It's a built-in feature of it. We have something called the heliospheric current sheet, which is a electrical sheet that's rotating, that when you look at the properties of it, it works a lot like a polarized filter if you see the properties and drill down on it. That only knows how to. That will also bring some optics into it, and along with one of the optics it does is any unknown solids, over like 70 or 80% of known solids that have more than one optic axis, it would cause a visual shift as it was rotating. An example of what that shift would look like would be, a perfect example would be the lunar wave, where as it crosses over, you see it redrawing. That's literally how the optics works with the electric field and the tech on it. We know that they measure that it's up there, et cetera, et cetera, et cetera. We can get into it even with redshift and blue shift, but we know perspective, how things come down and they tint down when we look at them. A matter of our eyesight. Curious Life, who no longer has it up, I need to find the videos, has some of the best technical information out there on how your eye operates, how the lens works. Good Times for All, you also have very good work on this. P-Brain has good work on this, but our eyes are going to resolve and bring things into it. So we know that triangulation, we know that a lot of these physics work, right? Triangulation works great with cell towers and with different things like that, as far as where we're physically touching and knowing where the items are, and the visual is very close. But when we're talking about light years away or light miles, or putting a whole different medium, they're not talking, I mean, they're pretending like there is nothing between it that is an optical effect. They take each one of their physics and they isolate it to make it work. But they have all of this physics there. They sell it to their scientists because in that one field, it is working in that one field. But as soon as you start putting the physics together, it goes out the window. Karen, you've looked, if we have any type of crystalline sky, you've looked it with me. You guys have all seen what the crystal can do and move the line. You can look through a piece of glass, through water, watch things move. I think the one thing that we can guarantee when looking up at the sky is things can't possibly, in physics, in real world physics, be where they are. Then you have the possibilities of, again, even natural projections or holograms or apparent focal points. And again, you're going to put your perspective into it. But the idea that the sky would triangulate and that we could get that distance, we play that it works small scale, but when it's the same. I'm going off topic, but it's the same like when we do the absorption spectra in the sky to get like the elements of the stars in that, right? I used to take absorption spectras. I know what the measurements are, but one of the things is you have to directly test it. You have to test the item the same with like a refractive index. You have to have contact with it. They're pointing a light at a sky, and again, as far as picking it up on color and what color lines it absorbs, they're putting it through all kinds of fields that affect the results. They're not getting a direct measurement. They are ignoring everything and running with little isolated bits of physics. And when you start doing it, everything falls apart. As soon as you, like with redshift, we can do this with anything in the sky. As far as the optics, it all falls apart. I
They're ignoring all of the filters that the light travels through. And so,
right, right, and we know magnetic filters have a. If you look at, I've done it myself, and I've showed people. Anybody that has been to the How the World Works exhibits that we've done, we've let the children especially play with magnets on a CRT screen. Ken Willer does it. You can see how it distorts the pattern and how it also shifts the color, because Kyle wanted to go into red shift, blue shift too. These things happen in reality. The physics of these items know not how to not do it. They would, in other words, a magnetic field does not know how to keep it undistorted. It will distort it the same every time, and it will follow a pattern. And we can use it to navigate by and what we optically see, but I can guarantee you, like in reality, I don't think it could be there. And so this is what started the discussion, and I'm going to let all of the people take arguments from there, but I think people walking into it, you didn't know our discussion going in or why we're having this show topic tonight. So with that, I'm going to stop sharing and let Zach and everybody continue. I know Skylar has got a really good presentation and is on time, so I want to get his in, and I know that he might not be able to stay the whole show. We'll see how that goes, okay? And let me stop sharing.
Sounds good. Yeah, in the background, I'm just showing a couple videos on
Perfect.
just different phenomena that we've found that takes place that we can create here in a lab. Now, I'm not saying anything like this is actually going on in the sky, but when you have two medium changes, different optical effects can take place. Like if you were down in that bucket, you would think that laser was pointing straight at you, but it's not.
and we know there's different mediums in the sky, though. So we've
Yes.
got
Exactly,
a lot of helium.
yeah.
Exactly.
So a lot there at higher altitudes, you get more helium. There's no point where it's like nothing. There's always something, and so the gases even change. Like you get a lot more neon up in the high atmosphere that you just don't have as much down here.
I see a clear glass with bent everything, right? No water in it. As soon as you add a different medium, crazy effects can take place. And we don't know what's up there in the sky. So these are just maybe pieces to the puzzle. We don't know if it's a puzzle piece or not. That's what's so interesting about this puzzle is we have all these pieces and we don't know if they apply to up there or not.
But we do know that there is no way that you can apply straight triangulation physics and have it make any sense at all in any logical
Absolutely.
fashion. You can like navigate and trust that they're there to navigate and look at and know what they're there, but you cannot know in reality, are they a projection? Are they another? We visually see them where they are, but I can tell you that is optical. And there is so much between us and there that the odds of the physics going back and forth and everything and then repositioning them back into the same place doesn't make sense. If somebody is looking at an angle across through atmosphere in Florida and somebody is triangulating in New York with it, they're looking through different amounts. If the star's right overhead for one person and at an angle for another, again, you have completely different conditions in all different ways going on for these people. It's not
the exact same weather in both places, and so there's
no.
different.
Again, you're looking through a different amount of medium. You're looking through. It's going to shift ones more than another. It would not be possible to triangulate. Triangulation is really great, and it is solid information in short distances. But again, when you're talking about doing it to optically things that you don't know what they are and are just pretending that you know what they are, and coming up with the distances that you are based on triangulation math and doing your numbers and mathematics and not thinking, wait a minute, I'm looking through a magnetic field, I'm looking through an electrical current, I am looking through possibly crystalline. They found it some kind of invisible shield. They have radiation. We have all of these things. And guess what? Every single one of those has an optical effect. Every single one of them.
Triangulation only works with straight lines, and unless
Straight
you know
lines and
exactly how
reality.
bent the lines are, that triangulation is no good to you. And so we're trying to measure distance to stars, distance to the sun, distance to the moon, and we're all trying to do this, but it's all got these crazy like refraction and different bending of the light that happens, and people are it's exactly what you're saying here about the bow fishing.
Mm-hmm.
Commercial
Thank you.
sound
Big
isn't.
shout out. Yep. Go
Yeah,
ahead, Cam.
thank you, Nathan. That's so kind and generous. We appreciate your support so much. Thank you guys for showing up and being with us, and again, working as we're trying to learn how to present more. I have always been in the background. I'm happiest there, but I'm here now, and I'm and I'm doing the best I can. But thank you all for the patience with going forward.
All right. So Skylar, did you want me to open up this?
Yeah, I mean, it's a little boring, I will be honest. Presentation may be a strong
I
word.
love boring.
I definitely got some cool stuff to show and talk about. So, and I think it obviously has everything to do with the topic at hand, right? The triangulation of things in the sky, which I do think is pretty important because, of course, if you've had any contact with any globers recently, then you know that they assume that everything is perfect Euclidean geometry, and of course, that means we can triangulate perfectly everything all over the place. Of course, not taking into account any of the electrical, magnetic, and if you want to go with their paradigm, gravitational lensing effects that can possibly occur at great distances, but everything's mapped out just fine. So here we have something to strongly consider when we're talking about making optical observations, and that is the direct measurement of curvature of visual space. No, it's not the Earth; it's of the space that we see in. So if you haven't seen this paper, it's actually quite good. A great abstract that leads to a bunch of other articles to strengthen your research on how it is that we actually see. I definitely advise that people always do their own heavy lifting a little bit. So, but in any case, when you read here, this abstract basically lays out the groundwork for, lays out the assumptions, right? So it says we consider the horizontal plane at eye height, that is all objects seen at the horizon. Although this plane visually degenerates into a line in the visual field, the depth dimension nevertheless gives a two-dimensional structure. We address the problem of this intrinsic curvature of this plane. The classical geometric method is based on Gauss's original definition, which is the angular excess in the triangle equals the I'm trying to read that, which is that the angular excess of the triangle equals the integral curvature over the area of a triangle. Angles were directly measured by a novel method of exocentric pointing. Basically, they took some steel rods that they knew were straight and level, and then they had a bunch of different observers to see what that looked like to each observer. So the observers were instructed not to move from the set location and to maintain eye height, but were otherwise free to perform eye, head, and body movements. And we measure the angular excess for equilateral triangles with sides of 2 to 20 meters. The vantage position at the bar center, we found angular excesses and deficits up to 30 degrees, right? Which completely blows out all of the MC Tune spherical excess. So we've measured
Yes.
the curvature of the Earth. They have at most like 1 degree, I think, and that's pushing it. And they only have one example of that. Most of them are well below that. And here they're finding spherical excess of up to 30 degrees and deficit, of course. So you can have it both ways. From this data, we construct the metric that the curvature changes from elliptic in near space to hyperbolic in far space. And then at very large distances, the plane becomes parabolic. So we actually have 3 different geometric expressions within our one visual space that we're seeing everything and making these observations from to consider. And I'm willing to bet my last dollar that none of this is taken into account in any of the curvature math or any of the assumptions that were made when we're looking at something like, let's say, Eratosthenes, right? This is one of the number one proofs that globers bring up. Oh, well, Eratosthenes was able to measure the difference in the position of the sun, therefore Earth is a globe. You push that out and you find out that that actually isn't proof. You need 3 observers. So then you have modern day people. Blitz PhD actually did one over on TikTok where they had like 20 different observers and did a Eratosthenes and measured the curvature of the Earth with using sun shadows. And at the same around the same time, a flat earther at the time, Riz Walden, was also doing an Eratosthenes experiment with the flat Earth assumptions. Now, what they did find was that when you have the flat plane assumption, that the sun seems to be at like different heights that won't necessarily work out for the observer, right? For the observers on a flat plane. And they claim that this is evidence that it only works on the sphere. However, if you incorporate the fact that we actually see in curved visual space and that everybody actually does have their own personal visual dome that they see within that's relative to their position, then it makes perfect sense. No, there's not literally multiple suns for every person, but it definitely appears to be in a different position based on their position, simply because of this right here, the direct measurement of curvature of visual space. Thank you. That's all.
It's just like different people standing on the shore looking at a fish. They're all pointing to a different location because it visually appears in a different location to them, but there's only one fish.
It's like
Yeah.
Snell's law, right? Is it kind of like Snell's law? Do you know what I'm talking about?
Right. Yeah, isn't Snell's law just the law of refraction?
Yeah.
Yeah. Well, yeah.
Snell's
So
law.
that's actually an additional thing to add in, right? This would happen with or without refraction. Refraction can actually maybe correct some of that curvature or add to it and make it exacerbated. It just depends on the angle of incidence, basically the direction that the light's coming in, and the medium determines how much it'll bend.
Yeah, but this is not the kind of curvature that comes from like a globe Earth or anything like that. It's just the atmosphere and different effects, things that affect the light.
Wow, 1621. Willow Broad Snell.
That's old.
That's old.
That's a little dated.
1621. Snell's law. But yeah, there's been a lot of research, and they're still researching into this, using these laws for stuff in computers that they're doing through fiber optics and this and that. And yeah, it's amazing how much physics have been, looked into on this subject. This is one of Cammie's subjects. I'm surprised she's not speaking up right now.
Well, I will add in with the whole, if we can't triangulate things in the sky, then why is it that we can still use it for navigation? And that's because we are basing our navigation off of their apparent positions. That's obvious.
Exactly. And they do maintain it. I'm going to jump in there too. I threw a screen share up for you again. And
okay,
I don't know what's there, but we'll play with you a little bit. For those of you who don't know what this is something that is it's a double parabolic dish, and it's a hologram created, or illusion created by putting something inside a double parabolic dish. And you'll find that when you do that, it creates it's known as a child's toy, a miroscope. And thank you, nobody sells any good ones anymore. After I started talking about them, all of the good ones went off of the market. I won't take it personally, but I do need somebody to make one. A natural hologram created this way, just so you know, because it's parabolic function, it can create light. It plays with light. It directly plays with light itself. It plays with flashlights. The hologram does, not the things. It can cast shadows. If I put foil in it and shine the sun, you can find yourself. These are like natural holograms created by natural features that are in our atmosphere. That, in other words, I'm working with things where they're in scaling them and getting it up. You can see what you're looking at is a hologram. I've stacked them up different ways. We have put into this stone, we have put an ice cube into it, for instance. And the ice cube, oops, wrong screen it went on to. I opened it up and it went to the wrong screen, and now I don't know how to, hold on. F11 was the key. Shift F11. I am seeing a neat video and you guys are not.
Yeah, you need to share your window, Cammie.
I know, that's what I did. It opened on the wrong one. But in other words, we've gotten ice. These are natural things that
we're still not seeing it.
You don't see it right now?
No.
Okay.
That's what I'm saying. You need to back out and go back into it.
I thought I did. Okay, we'll stop sharing and do it. Were you seeing any of the Miroscope stuff?
No, we saw your computer page with all the different thumbs.
Oh, so nothing. I've been opening. Oh, crap.
Yeah, that's what I'm saying. Share your window. All the way to the right.
Okay. Okay, let's try it one more time.
Okay.
It says share screen. I am so sorry. Not share screen. I'm going to window or entire screen. I have tab, window, or entire screen.
Entire screen.
Entire screen.
Thank
Yeah.
you.
Make sure you
Okay,
do the audio if you want the audio in the bottom left.
Okay. Okay.
All right. Okay, I see it.
All right. Let's crap because I was doing fun things too. So we'll start with where we left off and go backwards. Like the oh man, don't do it down here again. It just opened another screen. Let me drag it. Is it back up to you now? Okay.
Yep.
Yeah.
There we go. Like we have put
Can you make it
ice
fill the
bigger.
screen? Yeah.
Sure. I think so. Like that.
No, just go put your mouse over the video in the bottom third one from the bottom right. Yeah. No. No. Third one.
I
Bottom right there.
The third one over.
The little
Yeah, there
This
you
one?
go. Yeah.
Yep.
There you go.
Okay.
There we go. Okay, so what's going on?
So what's going on is you have a parabolic dish. You have an ice cube down in the dish at the bottom of it. And what we're doing is we're pointing a thermometer not in the dish or at the thing. We're pointing it at the hologram. We're getting the hologram to actually transfer the thing. There are better videos on Good Times for All and on my channel, Aislinn717. You can see like ice in a mirror scope and a much better where we are outside and doing a better job of it. This was just messiness on my stuff.
So you're taking the temperature of the hologram and it's
Yes.
reading as if it's actually there.
Right, and I'm putting my finger in it. You can feel the cold on the hologram. The better consistency of, in other words, this is a plastic dish. If you were to put metal inside or anything coherent or crystalline, it's a parabolic dish and does parabolic function. It's going to augment the functions coming on with it.
Can I
That
ask a
same.
question on that?
Mhm.
So when it comes to so you're feeling the temperature of the hologram as if it's
Yes.
the real thing. Does that mean that obviously not just the light properties are being transferred?
Correct. This right I'm doing is I am flashing. My flashlight is on the outside of the dish, and I am playing with
Full
light
screen again.
with the oops, full screen again like this. I am just playing with the light source. I am shining it at the hologram, not in the dish. I am playing and bouncing light off of a hologram. Everything is inside, and my idea from this came biblically because, and in other things, in the Bible they call the firmament. They don't call it a ceiling; they call it an expanse, and they give it qualities like looking
Okay,
glass.
Cammie, explain what this is and what's going on here. There,
It's
people in the chat are asking, how is this a hologram?
How is this a hologram?
So you're going to have to go back
You
to the
got it.
mirror scope and kind of explain what a mirror scope is.
Okay, we're going to take you back to a mirror scope and let's see.
Real quick, the firmament was also described as a hardened expanse to my
Right.
understanding, not just
Correct.
expanse.
Exactly,
Yeah.
a hardened expanse that has mirror-like qualities. And that when you make a hardened expanse, which an expanse to me is a top and a bottom, and you give mirror-like qualities, if you put it into a parabolic, I'm on the wrong screen.
It also says it's flat.
Okay.
It's hammered out flat.
It's hammered out. Okay. So a mirror scope is simply, think of it as a parabolic dish. It is, with a mirror inside of it. When you close one on top of the other,
So you have two dishes.
you
kind
have
of-
two
That
dishes
Kind of
are
like a
sandwiched together, yeah.
sandwiched together here. Let's
Like
see.
that.
Let's give you pictures. Here's multiple going. I had multiple. So here's the bottom of one. Here's the
Is there
top.
one sitting right next to you? Do you have one handy?
Yeah. Of course I do. Don't be ridiculous. So here's a little one.
These are about what, $10 to $15? You can
These
find
are like
them.
11, and they come and they are horrid quality. Right now they are coming already crackled, already peeling, brand new. They used to have substance to them. What I really need is I need metal and material, but these are, again, mirrored surfaces, nothing plastic, nothing special on the outside. So you're watching me. And if I put something into, let's just even find it and see if I can get it to do on live for y'all. Because again, I test in reality, or in other words,
It's going to be real hard for them to see
it's going to
it
be
at
hard.
that angle because you
It's
need to
hard
be
to get.
looking down at it.
You need to be looking
somewhat.
down at it. So I don't know. Let's see.
Oh, there it is.
Oh, there it is.
Wow.
So what you're seeing is a mirage. You cannot
You make your
possibly.
screen.
Oh,
You
yeah,
make
let
your
me
screen full screen now.
You're
yeah.
gonna have to do that. And this is fingerprinted dirty, and again on a bowl. So what you're seeing is not the real object.
Now open it. Yeah.
I can
and
try.
you-
Oops.
It's actually down there.
Way
in the
down there.
bottom. And when she puts this over the top, though, you're going to see it pop up right up there.
It just popped up here. I can.
And you can actually see the reflection of it.
Now, what's interesting is if I cut a hole in the bottom of it and float something on a string, I can get the hologram to appear as above and below. I can shine light. I can bounce light up. It can create shadows. In other words, you sit there and call it a children's toy, but it has all the parabolic functions that augment whatever is in there and actually focal point it and make it stronger. Just something to me really cool because again, it meets some of the criteria that it's an expanse. And the most efficient way to make a parabolic dish and to make it physically in physics work best would be, honestly, the noble metals, platinum, palladium, iridium. These all have the qualities of taking, augmenting, and concentrating. It's what we use for the functions of that. So again, if you grew the noble metals, or they say they hammered it out, or look at the expanse on that, all of a sudden you have something that very easily, again, creates some of the things, but it is a personal hologram, an aberration. Do I know this is what's going on? No. Does it make sense in physics that this could be going on? Could it explain a lot of the things, and does it meet requirements? Yes, but I do know I've about blinded myself with foil and different things with it, that if it catches the reflection, it does make shadows. It does do the things like that. One of the other things with and by the way, where it does the hologram is not, the hologram does not come directly above where it is in the dish. It crosses over. In other words, if I might have a picture of it. If gonna see what pictures we have of the holograms. That's an isotropic. That's a whole other one that's fun. I am not in the pictures I want to be in, but oh, watch this. This is illusions. Watch this.
Will you blow it up, Cammy?
Yes, this is a good one to watch.
Videos and bringing them together. It's so tasteful the way he does it. It sounds so crisp.
I hear Zombie Snoop. No,
That's
that's something in the background. Go ahead and
That's
pause
people
and
talking in the
mute that.
background. I don't know. Oh, here.
There you go.
Okay, can you still hear me and not him, or
Yes.
no?
Yeah.
Yeah.
Okay.
we were yelling though.
This is people in my background in the office, a party going on. What I'm doing is I'm illuminating. We're going to play this one again because I want you to see. I am just making a ball glow, and watch everything else on my desk. Watch where, as far as the optics. Watch.
Well, explain what those are.
These are little domes, like paperweights and domes. These are different half domes. I will show them to you. Oops. Like, I have them of all different sizes and shapes that we play with and experiment with. They make the paperweights.
They're all little domes, and they're all making their own image of the glowy ball.
Picking up this, what is very, very, very easy to get the optics to transfer. Optics transfer very, very easily, easier than you can possibly imagine. So getting the optics and the aberrations to transfer and to appear, especially when, again, working with magnetic fields, and that is very easy. It's getting the properties to transfer. It's getting the heat, more than just the optics. It's getting the heat and the other properties to transfer over to it. And that what works most efficiently in nature would be, again, as described, an expanse of looking glass that would create a parabolic function. I noticed that when I changed the shapes out of the dishes, made them deeper, shallower, and different things, what it did was is it changed just where the hologram appeared. There's, in other words, I can't have just a formula and say that, oh, the parabolic dish is this many degrees and that. I mixed and matched different ones, and again, for every variable I came up with, it created the hologram, but it just put it in a different place. Fun stuff. So again, when they're triangulating our skies and going through things, and it's what we're looking at, I guarantee you, when you're looking at those domes, that glowing ball that you see in all of those domes, it's not in any of them. The ball is right here. The ball is right there. You're seeing me show. I'm just making it glow in the dark, but the ball is not there. The ball is not there. The ball is not there.
And you can see, depending on what angle you're looking at the sphere, it's not in the same spot on each of those domes.
On any of them. And it will move around with where you're looking at it. I have some
Different sizes. It appears to be different sizes depending on how big the dome is. Yeah, that's really cool.
Mm-hmm. And we're using, by the way, for the fluorescence, we're using a natural fluorescence. This fluorescence and the way we're lighting is comprised of and made out of a stone called celestite. I usually have that on my desk. Oops, I've got a piece. No, that's not celestite. The celestite must be visiting my bedroom right now, but Karen might have a piece in front of her. But it's one of the most abundant elements. The biggest geode is made out of it, and again, it's what our fireworks and everything are made of. It's the stuff that we glow when you have the glow in the dark bracelets and everything. We're talking about made out of celestite.
It's over there.
Yeah, Deadshot Gaming in chat mentioned. I used to love this when I was a child. It follows you just like the moon does when you're driving in a car. I used to believe the moon followed me around.
It looked like it.
Yeah.
I remember watching the full moon from the back seat of my mom's car and thinking, why does it look like that thing's following us?
It's like we've been driving like an hour and it's still right there. Yeah, that always blew my mind.
This is fun. Oops, didn't mean to do this, but this one is fun just because when you're looking through and stacking and projecting different things, and I did it through holes in globes, that if I took and put an atmosphere in underneath it, and even a worldview, built it through and then came through the top, this would be upside down. I flipped it. I hung these from my ceiling. What's very interesting is from the top view, the way our atmosphere and everything works, when you look through the top, it works like a little reading magnifying glass that it does enhance. You don't see the whole view. You can like look in and focus in on little pieces of what's underneath. It's quite fascinating and interesting.
Yeah, we were.
Oops, wrong direction.
How do I make a double hole one of these where we can fill up the bottom? Yeah, there's so many things that we want to do. But I mean, these are kind of cheap. The ones we really want would be made out of some type of metal. Explain how that would be more beneficial, Cami, to have a mirrored metal instead of plastic like we have.
Okay, when you're talking about the functions of different things, remember properties are built into it. So for anybody, again, that's played with me and has done the hands-on, you'll notice, Karen, what did it feel like when you put a diamond up to an ice cube? What was the magic there?
The diamond transferred my body heat and like it just melted the ice instantly.
Instantly like that. Your functions of your platinum metals and everything are heat, electrical, thermal transfers. In other words, the properties they have and the properties they are so valued for are their heat transfer, their ability to concentrate, augment, and focus.
So you're touching the hologram with your finger and it's transferring the heat from your finger to the actual object. So it's kind of doing the inverse thing. So I know you were talking before about how if you touch the hologram, you could feel it cold, but it's going the opposite way too. You're transferring your heat from your finger through the hologram to the actual object, and that's melting the ice cube. Did I understand that correctly?
No, because you're doing a hologram, and we just even did a direct transfer of the properties of metals and that. Again, if you put the properties of, again, the parabolic dish is, the shape of it is focusing and augmenting, and you can again create perfect beams with it. But the metal gives in other words, your base, your metal or whatever you're doing it off of, is you're going to pick up the properties of it. In other words, if something transfers heat and reflects and can collate really and augment it more than anything. Augment it. It's going to take it, focus it, make it stronger. Your type of metals. It's why they are used where they are used, and they are so expensive and rare. Is they have properties. Look into the electrical conductivity. Look into the thermal conductivity. Look into the way that they can take the extreme high heat. Again, when you take properties one by one of what you have in your noble metals, which is ironic that they call them the noble metals, but just like our noble gases or what light up, there's some intelligence when you take the physics into it. A lot of intelligence, like mind-boggling intelligence. You get lost in it. You start playing with it and seeing it.
Do you think that's why they said it was like a copper plate hammered out,
Mm-hmm.
a vaulted looking glass?
A vaulted looking at, like, yeah. The copper and bronze, now you're going to have some things on that. Your platinum metals, it would work. Your noble metals would bring a whole lot more to the physics game. Again and again, we're just speculating, but in other words, if you add in the noble metals, that would make and again, metals are crystals. They grow out of the slurry. Karen can do it. They grow out of the elements that are there. They are part of the growth system. You can watch them grow. They're even more interesting than that. If you go into some work by Cleve, I think it's Cleve Baxter. I might be off on this one. He's with the plants, but I think this is too. This is work I was studying 25 years ago. They were taking litmus tests. They were taking litmus paper and growing, because again, all of these things can be grown in laboratory. Mercury, gold, all of these things can be grown in laboratory. They were testing and seeding mercury and different metals, and they actually grew better. They were testing daylight, nighttime, temperatures, different conditions. The thing that threw them was like mercury grew better when mercury was in the sky overhead. I mean, there were a lot of different anomalies that the metals and the growth of things and the action were affected by our planetary alignments, which again, in the heliocentric, everything's so far away and doesn't matter. And how could it have an effect? Everything really starts falling like puzzle pieces into place when you start looking at them. In other words, it's like the physics are there. We're just making stuff up or again, isolating things and talking to ourselves out of it, because nothing works in isolation. Everything works in a system.
Now, Bob used to love this girl. This is Physics Girl.
I got him hooked on her.
And this is Fun with Vortex. I'm just showing you this so you can see what, the possibilities of things that happen that we can physically produce down here. And this is just, yeah, I mean, then those things will travel all the way across the pool, leaving a shadow on the bottom of the pool. She did this one about 8 years ago. This blew my mind.
I remember
they
the day
just
this
found
came out.
If you put food coloring into it, they're actually connected. Look at that. That vortex is traveling through the pool as one full tube. It's not two separate vortexes. That's one vortex. We're just seeing the two shadows where it's interacting.
I have a really good
surface.
Zach, I'm sorry to cut you off, but
no, go ahead.
It's like a tube, right? So when you have it lower underwater, it actually forms a full ring. It's like you're just seeing half of the force there of the total ring that could be there.
Wow, and from beneath, that's what it looks like, a full circle.
Suddenly I'm thinking of rainbows.
Diana Cowan was great when she worked with reality physics and only got lost when repeating back like the astrophysics. It's just so hard to get your head around because it's quantum and it's entangled in it. She was fabulous until she went out of reality. Unfortunately, Diana, is not doing well. She one of the ones not so lucky. Not so lucky. She's no longer
Oh
well, no longer
man.
coherent. She's down. She was one of the people that got
Oh,
taken down. If you watch her
I'm
now, she
sorry to
can
hear
barely talk
that.
in that. Mhm.
Yeah, she was amazing. A lot of
If
the
you
videos that she made.
Don't
She
trust the
reminds
government,
me of
guys.
Action Lab. She really reminds me of Action Lab. They do a lot of the same types of stuff.
And that stuff is just so upsetting to me. It's ridiculous that can't say too much because we're still on the tube, I guess.
Yeah, we could go over to
Yeah.
Rockpen and give people a link over to Rockpen and talk that topic. We can't now. I would like
Yeah.
to, but it's if you would go to her channel, Physics Girl, and look at the most recent videos, they're not. It's not well.
When a government actively tries to reduce its population, that's when you know it's toxic.
Through they're reducing the population through there. Also, I don't know if other people, and we can't go there, but Mr. Gates is working on vaccines via mosquitoes as a way to help all the poor countries. They're going to infect the mosquitoes, and that way they can bite the people and they can get their vaccines that way. And that is what is in progress. And this is, I can send you the links. They are proud of it. They believe they're going to be helping the poor a lot. They're very proud of the technology they are working on taking care of it that way. And we won't talk about that more. But I will say that, yeah, I will say the Bill Gates Foundation is very proud of the work they are doing right now with mosquitoes, and that way they don't have to worry about poor people taking the trouble to get in and get their shots because these people are underserved.
It seems
And
like
somebody,
that's a lawsuit waiting to happen.
they're not going to be doing it. They're targeting countries. They might come here, but they're starting with my heart
The
breaks.
less desirable countries as they see them.
My heart breaks, and we need to go. We need to go to Rockpin or drop this. That's not
Yeah.
Diana now. Yeah, let's keep on going on topic with again on the optics. And I haven't looked at the chat.
Yeah, it's.
Oh, here's another one. Oops, I'm going to make this one big too. If you can put me on the screen.
Yep, gotcha. You're up.
Okay, I'm going to start it over. Whoops. Some daylight. Now we watch. I have the little globe going again. Watch. And there, Filthy, you can see more what you're looking at. You'll notice that a lot of the times they will, some of the discs they'll reverse in. And again, on the holograms, when we're doing it through the parabolic dish, keep in mind that it will put it on the other side. If you drop it in on this side of the dish, the hologram will appear on this side. It will counter it.
So you're kind of simulating the personal atmospheric dome that everyone kind of observes.
I'm seeing right here just how easy it is to again create the optics and the illusions. Those things are not in the balls. And then again, it's like nothing. I can do it from above. I can do it from below. Doing the optics is easy. All of the physics are there. Getting getting the functions to carry down with them requires a little bit more, because again, we know that we really do feel heat from the sun, and we know that the moon feels cold. But do you know what? If you can put ice in a hologram emitter and the hologram of it is cold and produces cold, to me, it just makes sense. And when I say a hologram emitter of this, I'm just saying like don't know if this is an answer. And here's one with again, I put tops and bottoms and that together. But it's a possibility that I look for possibilities that work in physics, in reality, when you combine them and testing them. Zach, say hello to your thermometer. I broke.
Yeah, I saw it. The gallon. I still have the little pieces inside from inside.
That
I
was.
want to get a big one of those. They have those that are like 4 feet tall with
Oh
like
yes.
60 of those little balls inside of it. Yeah, that would be cool.
Maybe if you're very, very good Santa Claus. Oh, that's right. There is no Santa Claus.
All right, I got this one I found. This is just showing, when light goes from one medium to another, it changes it. It's not where you think it's going to be anymore. This is something you can go try right now if you want. Just take a cup, put something inside of it, and then fill it with water. And you watch it bend. It's wild. A little bit from the side there, but when you look down from the top, it's even more off. But yeah, look at that.
And it's magnified.
Yeah. It is.
An important
Wow.
thing to note is that even though it's magnified, let's just pretend you could not see the top of the pencil there that's not submerged. You would have no way of knowing that that is refracted. There's no like outer distortion or anything that would tell you that that's not in the proper place.
Things can be refracted without obvious distortion, and that's something that globe earthers definitely need. I guess flat earthers need to know that too. That's kind of really important for talking to globe earthers about this thing. Is you point to all these things that happen on the horizon, and oh well, where's the distortion? Where's the distortion? Just because you don't see distortion doesn't mean it's not refracted.
100%. We lost you, Kyle. All of a sudden it went quiet.
I heard him.
Oh, just me. And okay, so
Yeah, he came through for me.
Mm-hmm.
okay, Blondie's looking at the wrong screen. So sorry.
Yeah, that's why we were on this one. We're more or less asking a question because we don't know what is above our heads. So we're just trying
there's
to.
atmosphere above our heads. We know that much.
Well, yeah, but
Yeah.
like the different mediums and this and that, and how different they are. And now, if it's a real gradual medium, like denser down here and less dense up here, say I don't know how it works.
That's what
Is
causes refraction. The
Yeah,
density
but
gradient is what causes refraction.
is it like if you went up to 10,000 feet and looked at 20,000 feet, it would be a lot different than if you were at 0 feet looking at 20,000 feet, right? The refraction amount would be different.
But it's still going to be there, and that's the problem with the globe earthers is they're always saying, just acting like there is none. And that's why they do all this like straight line calculations. There's one globe earther out there, Flat Earth Math, and he does all kinds of stuff, but he utterly strawmans the Flat Earth model, just like crazy amounts, just based on these straight line calculations.
Yeah, absolutely.
Okay, what's that's in the chat? Hi, Austin. It's good to see you. I'm not understanding your question.
That was to somebody.
Okay. On the hologram, does the hologram change appearance like a solid sphere as you
Oh, no,
change
okay.
viewing angle, or is it different? It looks, when you change your angles, you still see it as a solid sphere. In other words, it moves with your angles, not of it. It's really, I am so bad at articulating and so good at visualizing it. I can show it to you, and I have all of this stuff here to show and demo it, but I'm not understanding what the question is.
There's a limit to how far of an angle you can observe it
Yes.
before it starts to before the illusion gets broken. It's
Right.
not like you can go from any angle.
You have a sweet spot on it. Like if I hold it here, you have a sweet spot that you definitely, and again, my problem with doing your sweet spot on it is your sweet spot will change depending on the parameters I put on the dish. How do I make the dish? How shallow do I make the dish? And with all of it, it changes not only where the hologram appears, but what viewing angles you get. There are a lot of different variables. And I'm hoping you're welcome to join in and ask questions. They're great ones. So say I walk around looking at a ball and then I do that with a hologram. Would they change appearance the same or would it be different? No, it would be the same.
Identical.
It really looks the same. I'm asking because I'm trying to apply it to the idea of the moon over a plane to give context. It works identical. It does not distort. It does not distort with the different angles. It works like the moon. I believe I think I'm answering honestly and getting what you want, but I can show you. I can send you the different films of it again, or I have everything here if you wanted to play with it in different angles. And again, the one thing that I don't have anymore is I do not have any competent, like decent quality miroscopes anymore. I've got bunches and bunches of them around, but I don't know if this will show up exactly if I put it up to here. This is how they're coming to me. This is how crackly. This is a brand new one, and they are coming to me now that bad. They could not be any poorer quality, and I'm not. That's a brand new one.
And you gotta write it in. You gotta write reviews on this stuff.
It doesn't matter. They're not available. ThinkGeek and the places I used to
Oh.
get them are all out of business, and they anywhere you look, it's the same few crap ones. And again, there used to be multiples, even bigger ones and $300 ones and larger ones. They used to be abundant, and once I started talking about them, they are off of the market. I won't say it's me. I'm not a big enough channeler that to be out there, and I haven't even shared it enough, but it's frustrating because I've spent literally like 30 or 40 hours solid looking and trying to shop, or even looking at different ways I could piece together. I'm nerd girl, but frustrated easily. I'm not. It's like I can work with the pieces, but creating
I hear
them, I'm pretty clumsy. Pretty clumsy.
I wish making them was easier.
I know Chris Pontius could. I also know that Chris Pontius had really good work on that we did in person, and I have a video of that somewhere. I wish I could find where he makes the different parabolic dishes, and he had a clear parabolic dish, like again, suggesting the atmosphere, and it was an accident. He was holding it up, and he had a sign. He had a sign. What was it, Zach? 15, 20 feet. Were you there with Rob Skiba and everybody there?
Yeah, I actually did a video on
You
it,
do a
and I'm gonna
video.
pull it
Can
up
you
right
find it?
now. Yep.
This is so. This again caught me, and this would come from underneath. Now with the stars, when people make the black hole sun and do the different things in the hole underneath it, why he's looking for it, I will say that I've tried all kinds of different physics, and I could be missing something, but it's very, very difficult with our land over here in the small hole I would have at the North Hole to get the properties of the sun to transfer out to and reflect and come down and augment to the tropic of Cancer core. I almost need more of a direct line, but the stars that I'm not having as many physical properties or things to deal with on it, watch what happens here. What I mean, it's a very, very with the property is a very interesting thing. I got quite excited over there. I wanted to move in to Chris Pontius's laboratory. He had the wires, he had the stuff to make all of the stuff I wanted to play with.
And as we moved around the room, the star moved.
Stars, yeah.
So depending on where you were, determined where the star was in that little sphere there.
He's
Yeah, he's
touching
putting
it.
his hand right through it from
Mhm.
where I can see it. And where he can see it even. But that's
Mhm.
just a star lit up on the wall behind him. Now it is turned upside down now. I noticed that was interesting.
Mhm.
Because
It
on the
turned.
wall it's not like that. So it took the image and it inverted it.
It inverted it, and it made it so again you could put your hands through, and it in person it jumps out at you. It's like the star. Are you getting it at these angles? It's amazing.
And you would think it would be over on my side since I'm on this side of the dome. But I'm pretty sure I go to the other side of the dome here. Yeah.
I go and I look at it from all angles, and I'm getting it from all angles. And this is just a parabolic clear dish that he made and he folded with his wonderful equipment.
The actual light is behind you, though, right?
Yes, the actual light is on the wall behind. It's a sign on the wall, and again, he found it accidentally. And look, I mean, that's right. Everybody's trying to reach it. You can't quite believe it's not. We were loving this. We were loving this. I'm glad you don't have the
Oh,
video.
right there,
'Cause
it looks very
I think
3D. Like
yes.
this spot right there, it looks like
Oh.
it's floating there. You can see the effect really well right there.
I think I was squealing.
Yeah, you were making a lot of noise.
That right there is a really cool observation.
hmm
Yeah, I don't know why you're
And
being
there's the star right there on the back wall.
There it is, right
Next
there on
to
the
the
back
bar.
wall. See it?
Yeah, you don't need your mirror scope for that stuff. That's an even better demonstration, I think.
And it was
Exactly.
quite large too. I'm not sure if the closer he got to it, it got larger. But I noticed that when he was across the room, the star was only about, yay big. It wasn't really taking up that whole thing. But the star on the wall was pretty big. Yeah, that was wild.
That was wild too. Again, it's showing that the optics and what you see, if we triangulate to that star, those stars, all of us in the room, I guarantee you that that star is not where we're triangulating to. Just an example. Again, why are we playing on the triangulation and doing the math? It makes no sense. All of the stuff that we have in our sky would operate like these things because you know what? They don't know how to not. They
Well,
don't know
yeah,
how
if we
not
were
to.
on one side of this and someone else is on the other, that image we just showed you looks like it's in a totally different space. I would point way over here. The person on the other side would point at this side of the dish, and we would say that it's out here somewhere, when in reality, it's actually out here.
Ham Walter in the chat. Chad is asking, is it possible it's an optic illusion due to the concave curve of our eyes? I guarantee you our eyes and the way that we process it, again, we build cameras and that to off of what our eyes do and what we see. Our eyes are all these are, again, when you also isolate and do triangulation and things like that, you're taking all of the pieces that are there out of it. And that's why it does not work in reality. Of course, your eyes are part of the equation. They are definitely processing. And again, the way that we've all seen like the fake dragons and the different things, our eyes will put things together and process and make sense out of things. It's proven. It is the function of our eyes. It's how it works. So yes, the eyes do have a huge part of it. And is it illusion or is it reality? Again, you're touching it. It's there. Those are lights in the sky, or in a dish right there. And in reality, I don't think if we triangulated, I don't think how many people you put in the room and we triangulated no mathematician would get to where the star really is on that back wall. Just my opinion. I could be crazy.
And again, yeah, these are just pieces to a puzzle. Maybe not the puzzle we're trying to figure out, but it's still a piece that might be applied. That's why we're going over all these different things that could be taking place in the sky with different mediums up there. And we really don't know how far away these things are, what they are, their sizes, any of that stuff.
The major takeaway from this is no amount of straight line triangulation is going to tell you how far away that star actually is.
Yeah, exactly. And there is not a luminary in the sky that we've been to, unless you believe in the moon landing.
We can't just take a
That would
string
be,
from here all the way out to the star.
Yeah.
We can't measure it that way.
Measuring them I don't think it's possible without knowing either the size or a distance. You can't do one without the other.
No, we don't have the information.
NASA's full of crap.
We have a Mark Allen. We all know we live in a realm I think you mean simulation.
No, he's talking to
don't.
somebody in chat
Okay.
named Sim.
Okay.
Yeah. Yeah, they're having a disagreement. It happens.
It does happen.
We don't have to all agree on everything.
Nor will we, nor do we want to, because we need fresh ideas and, again, ways to, again, the topics need to be out there and open and discussed.
So what do you guys say? We'll wrap it up a little bit early tonight. It's a little over an hour show. Like we said, we're going to keep these between an hour to 2 hours. I don't want to go over 2 hours. I have to be up at 4:40 in the morning to do another show. So, but, I'm not hearing you.
Sorry,
Kyle.
I was saying, I think we're covering some really important points though. And these are all things that people really, really, really need to take into consideration if they ever hope to stand a chance against fighting against the flat Earth, if they can, right?
Yeah.
Because we see way too many people straw man against the flat Earth, and so if you want to fight against the flat Earth, these are the points you got to address. Okay, this is how you steel man us, right?
And if
These are points. Yeah.
And if your look is for truth, then you're basing it on reality and physics, and that again, with the physics, so many of them are good, but think about how you're applying them and the direct contact and the, again, the pieces and the parts you're putting together. So in other words, people say, well, Cami says triangulation isn't real, and it's like, no, I'm not saying triangulation isn't real and is not possible and it's not useful, and that it does not apply when you go through mediums. I don't think that there's any possibility in reality it can apply when you're going through the different mediums, and that they're saying is my thoughts. And if I'm wrong on it or that, again, I'm here to learn.
Juliet Lalone. Pardon me if I messed up on your pronunciation, but the sky looks further away from Argentina than from Oregon. That's interesting.
The sky looks closer in Hawaii and even closer in I'm looking for in Canada. Robbie Davidson, where did we have the conference in Canada?
Vancouver.
Edmonton. Okay. In
Edmonton.
Edmonton, I couldn't believe how close the stars felt in Edmonton. They were the closest I found to that was like at over 11,000 feet up in the Rockies, where you do feel like you can touch the stars. In case you wonder if you see the stars at like over 5,000 feet or a mile, I did have a cabin at right over 11,000 square feet. And I can tell you summertime was magic looking at the stars. They were unreal. They were huge, and you felt like you could reach up and, you really tried to jump up and get them.
Big shout out to Lord Racer. $10 super chat. Happy to be here with you all today. Always remember the abominable GLOBEBUSTERS.
Always.
Much love. Thank you very much, friend.
All of his thoughts in our conversations are going into this is all things Bob and I have discussed, and these are directions we're looking at. So we want to keep sharing. This is keeping Bob alive. Thank you.
Before we wrap it up completely, I did have one last question, and it'll be a quick one. Is it true that once you get to like a certain altitude, the stars like either get like very dim or you just can't see them?
Uriel was talking about that. He did the big balloon thing. I don't know. I haven't heard any updates on that recently.
Yeah, I haven't heard either. I've heard different things. I've heard people say that the stars have disappeared when they've gone up real high, but then I've seen balloon footage where the camera is set for it and they do pick up stars.
Seems to be an aperture thing then. One of the reasons why I thought of it is somebody in Rockfin had commented that if you get above the star hologram, I'm sure they're referring to the one that you were displaying earlier, Cami, that if you went above it, would you still be able to see it? I think you would.
I think so too.
But that's kind of reminds me of there being that sweet spot in the hologram, and if the stars are some sort of hologram, would there be a certain point where we would see their position change? Or
there could be definite clean angles, dead angles, just like again when we're playing with the like the miroscope, or I'm saying the hologram emitter. There are certain positions where you get multiple suns in certain angles, and most angles they don't pump into. In other words, angle has everything to do with all of these things. Your angle of looking at it has an impact. And does affect it, and it will fade at some of them. I do know, I can say embarrassingly so, ever since we've even been looking into flat Earth, the stars and disappearing was one of Bob's first things that was with the weather balloons, and that was something on our thing. So on every flight that we went on a night, it's hard in an airplane to really look up and get the good angle of it. And Bob liked the window seat, so and he could not crouch enough to look up and get the angle. So me laying across with my head and trying to bend my head like awkward and seeing, you can see less stars from the airplane window at night. Very few. You could see some planets and some lights at the high altitude. And I've done this on Hawaii flights, and I've done this on several different flights, and we've gotten weird looks on it, like, what's the crazy lady? We've had the stewardess, and it's like she's checking out different angles of the stars. It's okay, but my personal experience is at the higher altitudes, I saw where I would expect to see a lot of stars. I think I was only picking up the wandering or a few different other things. They were very hard to see and pick up at the angle and do that. But there were some. It wasn't black. I mean, I definitely picked up some. Karen,
Alrighty.
Yes.
what are your thoughts on any of this, and of course, Flattoberfest?
Well, I don't know. My thoughts on Flattoberfest are it's going to be a fantastic time. I think the schedule is pretty full now. I've added a couple people, but haven't announced it yet, and I'm not going to announce it yet. But
I know.
yeah, you know,
How are tickets? How many are available? I mean,
there's still tickets for sale, but
okay. I know they're
um,
going like hotcakes this year.
they're
excited.
selling faster than they have in the past. I can only assume it's because it's in Las Vegas. um,
Well, yeah, this is the first West Coast. I mean,
yeah.
furthest we've been out that way is Denver.
Yeah, right, exactly. So now we're in Las Vegas. We're within driving distance to Southern California. So, yeah, there's going to be a lot of people there, I think, and we're going to have a great time. We're going to have music. We're going to have raffles. We're going to have, announce it. No, Nathan.
Oh, teasing us.
Yeah,
But I think people will be excited when they find out who's going to be there. I think it'll be really cool. So
I can't wait.
got some I got some new additions this year. Quite a few new additions this year because like I said, it's international now. The borders are open. So
Vegas, baby.
yeah.
This will be my first time ever going to Vegas. So I'm excited.
Cool.
The nice thing is October isn't anywhere near as hot as it is right now.
Right.
Right now
never-
it is scorching.
I've never flown that way. Yeah, it's been hot here. How's your weather up there, Kyle?
It's really hot today. So,
Yeah, we were
it's
like
scorching.
98, I think. We hit. That's warm.
Yeah.
Mm-hmm.
I have a rain coming right now, currently 87, and if I look hot and sweaty, that's because I'm outside where I'm happiest. I have been, out here in the 90-degree doing the show. Feel healthiest outside. I like it. So thanks for putting up with it.
Well,
Yeah.
alrighty. Oh, go ahead, Skylar.
I was going to say, I heard that there was either it was a solar flare or magnetic event that happened last week or on Monday, or either that or the weekend. I can't remember exactly, but it was just really, really freaking hot, and it's been hot ever since then. So,
Yep. Yeah.
Ooh.
It's that time of the year for us in the northern, or the inner circle, I should say. What are you seeing, Cammie?
Oh, I'm seeing the I'm looking at the proton density is high, much higher than usual as far as solar wind. This is going to get into ionic and different things that, again, on there, checking out what we have. Again, I believe that there's some people collecting really good data on these pages. I don't agree with the way it's interpreted. And look at our auroras again, centered over Thule. KP index quiet is nice right now. It's beautiful. We are sitting at the south. Oh, holy crap. Let's share our screen on that. That does not. Hold on.
What are we looking at here?
I'm going to tell you as soon as you see it. And we're doing the entire screen. Screen 2, share. This right here is our boundaries. This is our magnetic boundary. They call this between our magnetic field on Earth and space. It's the boundary, and it says if it's magnetically going to the north or south. We live happily like with it on 0 or some to the north. When it goes into the south, kind of has full moon replications on people, but you have, again, it's what it does is it's a weak magnetic field. It's a weakening of it. And normally these scales sit from 0 to 5. Right now you'll see it's extended out to 20 on here. And we've actually dropped things off of the scale on the equipment. This is, I'm going to look at it a different way and see if it's also off of the charts I'm reading there. Look at this. This, people, yeah. Okay, I'll be looking at this afterwards, but this is, again, it's the relationship between the Earth's magnetic field and what they call space and the solar wind. And what they're doing is they're taking ion counts and density and magnetic readings in this, and you have scientists up in Boulder and around the world doing it. I don't think they're all lying. I think that they are taking these readings in good faith, and it doesn't make any sense at all, really, on the heliospheric model. I spent over 25 years trying to figure it out and trying to get the correlation between the volcanoes and what was going on with the sun. It makes no sense. But when you actually make everything and call this a shield there in local, you'll see everything again on the pieces start falling into place.
A correlation
When
between the sun and volcanoes?
Right. I was looking at sunspots and volcanoes and the way they affect each other. There's a different correlation,
Wow.
but they couldn't figure it out because you would think that the sun would cause volcanoes on Earth, but they were showing that the volcanoes and the stuff on Earth is pre-dating. It's going the wrong direction. So in the years they were trying to figure it out. So in other words, it seemed more like what was happening on Earth was affecting the sun. That makes zero sense whatsoever in their model.
Wow.
Right.
That like just begs for like a deeper investigation. Of
Yeah,
that.
we're gonna have to do like a
That's
whole
that's a
show
whole
on
show on it.
that.
That's
Yeah.
really fascinating. And again, a lot of scientific information. I've studied a lot of physics and works. That was kind of my nerd passion. I was a nerd girl before this. That was a lot of my nerd passion before, was trying to figure this out and trying to figure out the correlation. And I was hooked on it because there is one, but it worked backwards and makes a lot of sense if you make your sun small and local and put a little bit more. Again, if you change out the parameters, everything starts to fall into place and make sense, in my humble opinion. Okay, I will shut that. But this is a very, very unusual that it drops off and that it's extended so much.
105. Wow.
That's the clock app right there. Just checking on the clock app. It's a 105 right now. So yeah, it's pretty crazy.
Feels like Inferno.
Yep.
Well, alrighty, everybody.
Down here. Alrighty.
Kyle, what do you got going on this week? Anything new and exciting you're planning?
Well, I've got so much going on all the time. Like I say, I've got another. I just barely did a translation of one of Oliver Ibanez's videos about the Urbano Monte map, but NAOV, another Spanish channel, does another video about this whole Urbano Monte map, but makes some very different observations about it. And I think they're very much worth checking out. And so I think I want to do another translation of that. And then I've got some other stuff I really want to highlight on some other content. And so, yeah, I'm just always busy doing something.
Oliver Ibanez is another one I'm a fan of, which is great because I don't understand a word he's saying, but he sure shows the right visuals.
Yeah,
I can tell he knows what's going on.
Yeah, he's awesome.
He is. He's very, very awesome. Highly recommend this channel to everybody, especially our Spanish speakers. They'll probably even get a lot more out of it than I do, and I get quite a bit.
And I think they're a little bit less censored than
definitely.
We are in English.
Definitely.
All right, Karen B, what do you got going on?
Well, I've got anti-religious scripture study on Saturday as usual, and of course Coffee Talk on Monday and Strange World on Tuesday. And I always say maybe somewhere in between because sometimes I decide to do other stuff and I don't know. So that's all I've got going on, and then I'm just busy in the background working on the event and getting stuff ready for that, which is a lot to do. So That's what I'm up to.
Well, may everything fall into place smoothly for you.
Well, thank you.
Skylar, what you got going on this week, man?
Oh, the usual search for intelligent life over on TikTok is what I'd like to say. But unfortunately, I am banned. They banned me for misinformation. They actually told me this time. So there will be no flat smacking this Friday. It's going to have to be delayed until I can't remember. It's been like 3 days now. So maybe 2 days. I'll have to go back and look. Anyway, so instead, we're going to be doing an open panel, the True Earth Date open panel, searching for some guests, some good Globers, some people with some credentials. That way, they can't just lie left and right. We can actually have an honest, genuine conversation and try to get even more narrowed down to the truth of this realm as much as we can, anyway. So we have that going to be on Friday, and we also, well, that's tomorrow. And then we also have, of course, GLOBEBUSTERS on Sunday, guys. How can we forget to plug that amazing show, the GLOBEBUSTERS?
I forgot something that I need to plug too. I'm actually doing a debate with Wits It Gets It on Modern Day Debates this Saturday
Oh, nice.
at 8
Nice.
o'clock.
Very
So
We'll be there.
Who are you up against?
I don't know, 2 Globies.
It
Yeah,
doesn't
matter.
doesn't matter.
Doesn't matter.
matter.
No.
Yeah, you guys will be a great team on that.
Well, it's the second one we've done, so
I'll
Awesome.
definitely be
Should
in
be
the
fun.
comments of that. Definitely be in the comments of that. But yeah, GLOBEBUSTERS on Sunday, and yeah, we pick it all back up from there.
All righty, and Cammy, what do you got going on this week?
Oh, I have a day tomorrow in all the county buildings and everything. So a day of paperwork hell that I am dreading the hell out of. So nobody wants to care about that. But I will be in the chat room rooting on our primetime GLOBEBUSTER stars. Can't wait for the show on Sunday. We have Iron Realm on Friday night if I'm
Yeah, tomorrow night.
tomorrow night if I still have anything left inside of me. And Monday is my birthday, and we're hoping to start fresh and move forward and do positive things and start preparing for Vegas and
Vegas, baby.
a day at a time.
Day at a time. All right.
The sun will shine.
Hmm.
And you all can find me over at Iron Realm Media Tuesdays and Friday mornings, 5 a.m. Eastern time, and then Friday night, precisely when we're meant to show up. That's when we show up. Usually between 6 and 7, but yeah. And this is actually what I'm working on in the back screen here. I started making a flat Earth map for Fortnite, and it's coming along nice. We
That's
got
awesome.
We're gonna put the Flat Earth Yacht Club out there. We've got just a farm in the Midwest, but we do have flat Earth farms out here in California.
There are so many flat Earth references to that game. I'm telling
I
you.
know. There's just little stuff here and there. Yeah, it's actually coming along pretty good. You can see I've added more to it. I got most of the land except for all the islands.
You gotta drop a link to your username so we can look for you on Fortnite and add you as a friend.
Oh yeah, it's good times for all.
Oh, okay. I'll
Nice.
Same
see
as
that.
on yeah.
Yeah, we gotta catch some wins, man.
Oh yeah. But yeah, this is really neat. This is the actual editor they use to make the Fortnite maps. Oh, we got the Pillars of Hercules at the Strait of Gibraltar.
Nice.
that's pretty cool.
Yeah. The Great Pyramid. So yeah,
Well-
it's neat. I really enjoy doing this, making landscapes, and we
You
got to
gotta
put trees in.
You gotta put Atlantis out from in that water somewhere.
I was thinking about it, possibly. We have the 2 pillars, one on each corner here. And then we're going to have bases. There's 8 military bases, just like the UN has, all around the edges. And we're going to make it to where there's going to be stuff out there at the military bases that you have to gather all of them and then bring them all back to the center here to Thule Air Force Base to unlock a vault or something like that. It'll be like one of the Easter eggs in it or something. But yeah, I just want a map that, kids can play and show their friends, hey, look at this is what the Earth would look like if it were flat. You just get the
And this
ball
is
rolling.
yeah. It's not meant to be accurate to scale to measure off of or for debate things. This is fun things with little features to run and play. And again, it's a Fortnite game that you scale it down. I've watched them run the characters through it. They're putting fun little captures and what was I won't even say there was a feature you guys were going to build into it that was very, very cool. That I'll keep it as a thing that what you were talking with my son about. Can you make it do that? They have. It's so cool. I'm not gaming. I'm so fascinated by
There's
this, and it's
actually
so fun.
a great flat Earth proof on this, Zach. If you put the character all the way down to ground level and you look across, you'll actually see that you cannot see the full things, right? The bottoms are actually blocked. And guys, we
Yeah.
can actually go up above this thing. We know there's no curvature. So checkmate.
Yeah.
Excellent.
But yeah, that's what I'm working on. I just want to show people the progress I've made. I've been putting some time into this. It's
Yes,
fun.
Daryl Davis, your farm is on there.
Yeah, Flat Earth Farms, baby. There's we're gonna put some signs up and everything, but you're up in the mountains of California. There's the
Awesome.
farmhouse. And I'm gonna put a desert in right here. There's gotta be like a Grand Canyon, something or other. I gotta put like a hole in the ground at least. I
At
just
least.
realized that, yeah. But yeah, that's what I've been working on.
You got the West Coast pretty green over there.
Yeah, I know. It's not very accurate, but that's what we're hoping it's gonna look like one day again for Daryl and all the people out there.
Yeah, out here, I need some greenery. I'm just drying up out in the desert out here.
Well, alrighty, folks. That's gonna do it for us this evening. I hope you enjoyed the show. Remember, be good to each other. Be kind. Open your heart, because there's truth inside. Peace out, everybody.
Peace.
Peace. Thank you, everyone, for coming.
Thank you.